Let's learn what is biomechanics.
What is the importance and exercise of the biomechanics? So we have here, it promotes proper form, improves our movement efficiency, reduce risk of injury, and helps apply the correct forces. And that would be all.
Okay, so next we have the importance of exercises. So first, it promotes proper form. So it means that when you are doing exercises the right way, when your form is correct, your body moves properly and safely. So for example, when you are lifting weights, your posture should be straight to avoid injury. Second, it improves movement efficiency. So biomechanics helps your body move in an easier and smoother way. So you don't waste too much energy and you can perform better and not get tired quickly. And third, it reduces risk of injury. So when you understand how your body should move, you avoid wrong movements that can cause pain or injury. It keeps your muscles and joints safe. And lastly, it helps apply the correct force. So this means that when you are using the right amount of strength, not too weak and also not too strong, it helps you control your movements better, like when you are jumping or lifting. Okay, so next, we have Jerwin to explain the examples of biomechanics in daily life and sports.
So here are some examples of biomechanics in daily life and sports. Number 1, running. So running involves coordinated movement of the whole body. In biomechanics, proper foot strike means landing on the midfoot or forefoot to reduce stress on the knees and ankles. Good posture, keeping the body upright and relaxed, helps maintain balance and allows smoother and more efficient movement. Number 2, lifting weights. So when lifting weights, biomechanics focuses on keeping the body in the correct position. Proper body alignment means keeping the back straight, bending the knees, and using the legs instead of the back. This helps prevent injuries and allows the muscles to work safely and effectively. Number 3, jumping. So jumping requires strong use of the leg muscles. Biomechanics explains how the body applies force against the ground to push upward. The more force produced by the legs, the higher the jump. Proper landing by bending the knees helps absorb impact and avoid injury. Lastly, 4, walking. So walking is a basic movement that uses balance and coordination. Biomechanics shows how different joints like the hips, knees, and ankles work together smoothly. Maintaining balance keeps the body stable, while proper joint movement makes walking efficient and less tiring.
Hi guys, I'm Anton and I will be the one to explain to you about the elements of biomechanism. Hello everybody, so today I will be explaining to you the 5 elements of biomechanism. We have 5: the motion, the force, the momentum, the lever, and the balance. So let's begin with motion. Think of this as what happened of movement. It is the change in position of your body in space. We have 2 types of motion, that is linear motion and angular motion. Linear motion is moving in a straight line like a sprinter. Angular motion, moving around the axis like a gymnast spinning on the bar. It has 2 factors including in motion. We have the speed and acceleration. What are those? They're not the same actually. People have that misconception about that. Speed is basically how you move from point A to B. And acceleration is how quickly that speed changing. Next, we have the force. This is the why it happened. Nothing moves without force. It is a push or pull that acts upon an object. We have the internal force, which means inside our body, the muscles contracting to pull on our bones to generate force to push or pull something. External force, external, outside the body, top of your head, What force is there outside our body? Gravity, of course, and also that includes, in physics, friction. So basically, in simpler terms, force is what starts movement, stops it, or makes you change direction in midair. Momentum. In simpler terms, think of momentum as a chunk of mass on the move. The more momentum you have, the harder you are to stop. It is discussed thoroughly in physics. It has a formula in which it is expressed as P equals mv, where P is momentum, and m is mass, and v is velocity. They are directly relative, so the more of mass or velocity, that means you will have higher momentum. Imagine a 250-pound basketball player running at full speed. Of course, it has much more momentum than a 150-pound basketball player running at the same speed. So to stop that 250-pound basketball player, you will need higher force. Next, we have the levers. Our bodies are essentially a collection of biological levers. Our bones act as the bars, and your joints act as the pivot points. A lever needs three things. The first, the fulcrum or the axis, the joint where the movement happens. Example, your elbow. The second one is load or resistance, the weight you are moving. Example, a dumbbell in your hand. I don't have a dumbbell. Third is effort or force, the muscle pull that creates the movement. For example, our biceps, in which mine doesn't exist. I should have gone to the gym. And 5 is, of course, the balance. It is the ability to maintain stability. Oh, what a rhyme. It is all about where your weight is located relative to your feet. We have elements in force, the center of gravity, the imaginary point where your body weight is perfectly balanced. It is found near our belly button. Second is base of support, the area on the ground you are touching. Our feet, the floor of your house, anything. The golden rule is that as long as your center of gravity stays directly over your base support, you stay upright. If you lean too far and your center of gravity moves outside the base, you fall unless you apply force to move a foot and create a new base. That's all from me. See you next time.
Welcome to the principle used in biomechanics. The first principle is the dynamics. The dynamics is the study of moving systems that undergo acceleration and deceleration. For example, dropping a ball in a second-story classroom, and watch how the gravity accelerates and decelerates when it touches the grass. For the second principle is the kinematics. Kinematics is the study of motion of patterns that describes the effects of forces on a system, including the linear and angular variation in velocity through time, position, displacement, speed, and acceleration. For example,
Rolling a ball in a linear motion, and as you can see, it is fast and can travel far.
the first was the linear path. Now, let's go for the angular velocity. Spin it for a curving arc. See how far it goes slowly compares to the linear path. Pure displacement magic! The third principle is the kinetics, the study of what generates motion and forces and duration at work. For example, forces creating a motion, Luke's foot forces and launches it. Gravity pull and net floor stop it. Force and duration is kinetics. The fourth principle is the statics, the study of system of equilibrium, whether at rest or moving at a constant velocity.
So now we will proceed to the applications of biomechanics. Biomechanics has many applications, not just for an athlete, but also for a person who enjoys exercising. We all know that moving our body during vigorous movements is hard enough. What more without the comfort while doing so? As we all know, biomechanics basically enables us to move smarter, not just harder. It involves observing a certain movement, analyzing the areas for improvement, improving those areas, and performing it safely. So now we will discuss the 3 applications of biomechanics and how these applications enhances our way of moving and how we can move safely while doing vigorous movements.
So let's proceed to biomechanics. First, what is biomechanics? Biomechanics and physical education analyzes movements to optimize athletic performance and prevent injuries by applying mechanics and physics principles to human movement. Key applications include correcting movement techniques, understanding internal or external forces, improving equipment design, and reducing injury risk, such as identifying improper landing patterns or inefficient throwing techniques.
Application of biomechanics can be used to design innovative medical treatments, like the usage of orthotics and prosthetics. Orthotics are supports that helps correct body alignment, like braces or shoe inserts. They help fix body position, for example like your feet or knees, so that a person can walk without causing any pain. On the other hand, prosthetics are artificial body parts, such as arms or legs, designed to replace missing limbs so that a person can move again. Biomechanics helps engineers these so they move as naturally as possible, matching the way muscles, joints, and bones normally work.
Okay, so for the third application of biomechanics is that it is applied in the design of sports equipment. So for example, when creating running shoes, of course, makreate ka gid running shoes for the comfort of the runner so that the runner can run for extended periods of time. The purpose of biomechanics in this situation is to design equipment that can improve athlete performance while reducing the risk of injury. If you provide cushioning for the sportswear of the runner, then of course you will enhance his or her performance because you're giving comfort to his or her feet. Another application would be the design of tennis rackets. So biomechanics helps analyze how the arm, wrist, and shoulder move during a swing. Based on this, rackets are designed with the right weight, grip size, and string tension to improve control and power while reducing strain on the wrist and elbow. So diba, all of this is designed for the comfort of the athlete or the person doing the movement. Because of this, it enhances their performance for them to win the sport, get gold, or maybe just enjoy doing that movement or doing their sports without the pain or with the comfort of doing so, with the comfort of doing what they love.